Good afternoon, everyone. I hope you all had a good lunch. So most of the times, whenever we talk about frameworks or libraries or packages, we talk about those set of frameworks which work well together. For example, a few years back, correct, Redux was a default choice in any React project, correct? Even today, correct, if I'm using Python, you always name Python Django, Java Spring Boot, Ruby on Rails, correct? So these frameworks kind of work well together and kind of feel like a match made in heaven, correct? They're supposed to work well together. Now this particular talk is actually totally opposite of this idea of two frameworks working well together. So these are the two technologies which work well independently or with other libraries, but when they are made to work together in a single application, they doesn't work well. And that is why the whole idea of saying that SSR and web components are contentious couple. So you are going to face issues if you try to merge them together in a single app. So before I move to all the issues that you can face, I just want to quickly summarize about these two technologies, how they work, what are those, and just to set up the context with everyone. Just a quick one, how many of you have used SSR, server-side renders app till now? And how many of you have used web components? Okay, cool. So a quick summary about how SSR works, correct? Server-side rendered apps. So user requests a site. So server, instead of just sending a plain index.html with just an ID so that a framework can hydrate or bootstrap on the client, server creates a full-fledged HTML and browser like sends back on the wire and browser that render that HTML, which is not interactive at that point of time. But as a user, I can see the whole page generated over there, correct? Then the browser with the first script tag renders the whole JavaScript, your bundler, your bundle.js or index.js file, which then it gets executed on the browser, and that actually makes the website fully interactive. And that process is called hydration, correct? So React hydration. Any server-side app actually behaves like that only. So you render the HTML, download the JavaScript so that it becomes interactive on the client now. So that is a very quick summary of what SSR is, correct? How it is different from CSR? Again, in CSR or client-side rendered apps, so you don't send the whole HTML on wire, but just the initial index.html with a JavaScript file, which has all the framework bundle plus your application bundle, and it starts working on the client. Yeah, so we talked about hydration as well, why it is important for interactions also. So why the whole world is moving back to SSR apps, correct? SSR was there 10 years back as well. Then suddenly the whole ecosystem moved saying that no, CSR is the way to go. And now the whole circle of life is coming back and saying, no, move back to SSR, correct? Like just making your life miserable, nothing else. but yeah, there are advantages, correct? What the community has realized working on CSR and then moving back to SSR, and these advantages are like what is mentioned here: search engine optimization. Because we are actually sending back the whole HTML, all the nested links into it, all the semantic markup is there, correct? For the crawlers to index your page better, for better SEO ranking as well. So that is one of the major advantage of server-side rendering apps. Then faster loading time, again, because of the same reason, you don't have to wait for any JavaScript execution to happen on the client for the application to start working, correct? You can see the whole full-fledged application there itself, which increase your perceived performance also. So that is another major advantage of SSR apps. And last but not least, there are other advantages as well. It actually helps in improved data security. The reason being, in contrary to CSR app where you have to expose your tokens, your secrets on the client, correct? And then had to secure it in different ways. In SSR apps, you don't need to expose that on the client, correct? Because the whole HTML is getting generated on the server, you can just send it back to the client, and client is just responsible for that rendering of that HTML rather than all the secrets being exposed on the browser. So now very high level, these are the three major advantages of SSR and the reason of the ecosystem to be moved back to the SSR apps rather than continuing with the CSR app. Now the second technology, correct? Web components. What are web components, correct? So if I just read the definition out here, web components are a set of web platform APIs that allow you to create custom components, correct? Which are reusable, encapsulated, and keep it separated from the actual HTML DOM for all of its advantage. So one of the major advantage of web components is an element called shadow root or shadow DOM, which helps you to create that nested encapsulation within that component so that all the functionality or your styles are always encapsulated within that web component only, so that and you don't feel or you don't face any fear of collision with the other parts of the document. So for example, if I'm styling, so this is a web component called my drawer, correct, which has a shadow root inside it and all the HTML into it, correct. So when it gets rendered on the browser, if I'm having any styles which are applied to drawer header or drawer content, even if I use the same CSS classes which are exposed in the main HTML document, they are not gonna create any style ambiguity. Whatever APIs I'm gonna expose within that web components are very local to that web component, and it is not gonna again create any ambiguity with the functionality outside of that component. And that's the major advantage of using a web component technology. And that is what makes web components special as well, correct? You can create reusable components very easily, and these are native to HTML, native to your web browser APIs as well. So you don't need to use any special framework to create web components as well. But one question arises here, correct? So if I'm saying my drawer as a HTML element, correct? How does browser understands that? Browser understand what is already available as an HTML element, as a div, as a paragraph, as an input. But how does HTML actually understand what my drawer is? And that is where the whole idea of defining a custom element comes into picture. So browser is exposing an API on the global window object, which says that you can tell me that my drawer is a custom component, custom element, and this is the implementation of it. Now, till the time this line is not executed on the client, so this is very important in context of the whole next session. Till the time my web component is not getting registered on the client, it will not work, because my browser is not going to understand what my drawer or my custom component is. It will just bluntly show nothing to the client or nothing on the browser. So just keep a note of it, because the whole thing will revolve around the same topic. Now, why do we use web components? There are different advantages. First of all, it's a framework agnostic solution. You don't need to use any special framework to create web component. These are native to HTML, native to browser APIs. There are some framework which have built an abstraction on top of web components, something like Stencil, there is lit elements and so on, correct? But once they bundle it, they expose only the native web components, nothing special. So that means you don't have to expose or don't have to render any special library code on the wire. You don't have to send that, like how React works or Angular works, correct? Till the time that framework is not on the client, that framework components are not going to work, correct? In case of web component, you don't need to do that. Once it gets registered, it works. Second advantage is it provides style encapsulation. I think I just talked about that, how it provides that and what is style encapsulation as well. And that is one of the biggest advantage when you are creating design component library with web components, correct? So you want to avoid style ambiguity in your design component library. And that is why the web components are mostly used for creating your design system, design component libraries. Last but not least, it provides better performance as well. The reason being, again, it somehow relate to the same thing, framework agnostic solution, but better performance because, again, you don't have to wait for any special framework JavaScript to be on the client to make this component work. So that means you're not waiting for that. Once it gets registered, it will start working, and that actually gives you a better performance also. Cool. So now we have talked about a quick summary of these two technologies, correct? Which has their own advantages, somehow related as well. SSR also says how I'll make your application better performant. Web components are saying the same thing. But then when these two are actually going to use together, maybe these advantages are not going to be there anymore, and it can work against each other also. So before I move to, again, the issues that we faced in the application, I just want to make one disclaimer here. So this talk is not against any technology, any framework. It is with the experience that we faced in one of the applications that we built in the past. I was a part of that team where we used web component stencil, where we used stencil as a web component library to build design system components and used those components as a Next.js SSR app. And all the issues that we faced when we use these two technologies together. So again, nothing against any framework. They are all good, given a scenario. Cool. Any questions till now? I hope all the audience is at least clear about the two technologies individually, correct? Now, let's move on to the first issue that we faced, correct? And that is one of the major advantage of an SSR app, correct? Search engine optimization. So now, when I was just talking about SSR advantages, this was the first benefit of it, correct? My SSR apps gives you better SEO ranking. And that was one of the reasons when I talked about that the whole ecosystem, front-end ecosystem is moving back to SSR apps, correct? But here I'm saying that, if you're using web component design system or design components in an SSR app, your search engine's optimizer or SEO score is gonna get impacted adversely. And how it is, and that is what we are gonna explain here. First of all, a quick summary about how SEO works, correct? I'm not gonna go into details of SEO. I'm not an SEO expert as well, but on a very high level, how SEO works is like you publish your content, you publish your HTML. The crawler scrolls a page, correct? Let's say any retail site that we are working on, correct? A crawler will crawl that site and figure out what are the nested links to it if you are using the semantically correct HTML to it, so that it can index it and use that index ratings or rankings to show your application or website in the search results. So one of the major element that works in a better SEO ranking is your anchor tag, correct? So if my crawler is crawling the HTML page, if it reaches an anchor tag, it gets to know that there is a nested link. And I have to index that link so that if a user searches for a particular PDP page, let's say that link is saying that I'm going to a particular PDP page, if that crawler has indexed it, next time a user search for that page, it can directly show you in the in your search results as well. So on a very high level, that is how SEO works, search engine optimizations or crawlers works. One thing, again a statement which says that a Google bot, correct, doesn't click on anything, so you need to use links in your render HTMLs. So it not automatically clicks on anything. A bot or a crawler doesn't click anything. is just try to find out what are the nested links available in your HTML. Another thing to notice is that a lot of crawlers, correct, a Google bot or a Bing as a search engines actually index JS websites as well, a CSR apps as well. But let's say that if you are making a global website which are gonna use like across different countries, correct, where in some of the countries maybe the Google search engine is not working well, correct, so there are different search engines which you want your search engines or which your crawlers to crawl your website. So that means you don't want to rely on just one search engine for you to work, correct? So you have to figure out what are the different search engines available there, and instead of relying on just the CSR technologies, you work with the SSR as well. So let's now talk about if I'm creating a web component for a link, correct? Again, I'm creating a design system library and a link is an atom in that library, correct? Usually this is how I'll create. Again, a very naive way of representing a link, but I'll say that, oh, this is my link which will route to page1.com and it has a title, whatever the user will see as a go to page one. That's all. That's how I will create. I'll not showing the implementation of that my link, but that is how I'll try to write HTML4, correct, in my HTML page. Now imagine that a crawler is crawling the page, correct? Nowhere it actually finds out where the anchor tag is. So that means if you want a good SEO ranking for your page1.com, it will not be able to do that because of unavailability of the nested links, nested anchors. And that is just one of the example where your web component can impact your SEO ranking, correct? A link is a very important element to that. So that is how it works against each other, correct? So I'm going to talk about resolutions of each of these issues as well with all of those. So one of the way to solve this problem, if you really want to use web components because of different reasons in your app, is use slot-based approach. So web component technology has a mechanism of providing a slot to your component, and inside the implementation of my link, I can just say that read this slot. So if you're using stencil, correct, it's very easy to say that, oh, put that slot or put that template where the slot name is an anchor. But if you are using a native web components, there's a big steps to do that as well. But if you see this, now I'm able to do the style encapsulation with my link, because I can say that whatever there is, there's an anchor tag within that my link, style it like this. So my problem of style encapsulation is solved with web component, and with anchor tag available in the raw HTML that you send on the wire, the SEO optimization is also solved. So it is able to find out how there is a link which you need to index as a crawler. So that is how you can solve that problem if you have to use these two technologies together. Any questions on this? Are we clear on this? Cool. So the next issue is performance degradation. Okay. Again, in both the technologies I talked about, that SSR is performant, web components are performant, but together they actually impact the performance adversely. And one of the reason of this is, and one of the the major reason of this is that web components actually need to get registered on the client, correct? So even if I am sending a web component with the slot-based approach within that HTML, till the time it is not getting registered on your browser, on your client, it is not going to work. Correct? So that means that time period of that element going to get registered on the client versus what you get over the HTML or over the wire, there is a huge difference between that time, correct? And that leads to performance degradation as well. So now imagine that, this is with my experience what I have faced, like you have created a whole big library of components, correct? And usually when you are creating that design system library, you have n number of icons as well. You have n number of atoms, then molecules, if I talk about atomic design system, correct? Suddenly you are saying that, oh, whenever a script tag is getting rendered on the client, that script tag is just for registering all the n number of web components on the client, correct? So that can cause the HTML blocking, render blocking issue as well. I hope you understand what it's render blocking scripts, correct? Because that script has to wait for all the web components to get registered on the client. That means till that time, I can clearly see a white screen as well. If all my components are not registered or all my components are actually web components. So I can clearly see a white screen till the time all those components are not registered. And we saw that, like with my experience, we actually saw that white screen. We were using speed curve as a performance tool. And suddenly when we implemented that web component design system and try to measure the performance, we could see that for, let's say 2 seconds or 3 seconds, there was just a white screen because there was a script working to just registering my web components. And a lot of time was taken to register all the icons. There were like thousands of icons with web component that we are creating. That was a problem there. So again, both actually impacted the performance in an adverse way. So how can we solve that problem is again by kind of a way we tried. For some instances it worked, for some it didn't. Something called as a lazy registration. We said that, oh, register only those set of components which should be the priority for a user to see, correct? So let's say header have a links, which may be an icons as well, correct? An avatar or anything that you want user to see as soon as possible. So just register those elements first lazily or first, and then once the screen is ready, lazily register all the other elements. So that means the perceived performance with this case can be better rather than waiting for all the web components to get registered on the client. Another way is, I'll talk about that in later part of this presentation as well. But another way is that you can actually use custom elements.get API to find out if a web component is already registered or not. So if it is already there, don't register it. That's all. Just to avoid like registering it multiple times. Cool. So third issue. How many of you know this problem, flash of unstyled components? I'll quickly show you what is a flash. So a blank screen, correct? I'll just gonna refresh, just see how the content goes from left to the right, okay? Did you notice that in the top left corner, it just goes to the right, correct? So what is happening here is, this is a very basic, I haven't styled it just because I wanted to show you the actual problem here. So this is a drawer again, correct? So the default behavior of a drawer is that my drawer is on the rightmost extreme. Whenever I say click on a button, it should open up from right to left. That is the functionality of my drawer right now. But because there is a flash of unstyled components happening, what it does is that till the time that web component is not getting registered on the client, I'm seeing that native styles being applied to that slot based elements, correct? We saw that drawer which has header, footer as slots being provided to it. So that means till the time my web component is not getting registered, I can see those slots or divs or whatever elements I'm passing to it as a flash of unstyled components as well. So if I move back, so that flash is just with the browser native styles, what it applies to different elements, correct? Right now I'm just using divs, so it doesn't have any styles. So if you have an H1, H2, whatever being passed, correct? It will just apply those native styles to those elements. So slot-based approach, though improved my SEO ranking because my anchors are there, and it also gives you benefit to pass any content to your element as well. For example, drawer, correct? I want to pass any header as a drawer header, or any content as a drawer content. So though I got those advantages, but I face this issue of flash of unstyled components with that. And again, just repeating the same line, till the time web components are not registered, the encapsulated styles does not get applied. So how do you resolve that problem, or how did we try to resolve that problem is, again, not the best of the solution, I would say, but we said, okay, hide the slot element using CSS visibility. Because we were kind of stuck with web components there. That was a business decision taken to use web components, in the SSR app. So we were trying to resolve everything, whatever we were facing. So this was the simplest way that we tried. We said that, oh, till the time web components not registered, hide the slot element with visibility. But then we also face the problem that if I have a valid style inside that slot which says visibility visible, correct? So how visibility plays is that if you have visibility hidden, but if any nested element has, say, visibility visible, that will start showing up again. So that adds another complexity saying that even if I'm adding my visibility rule to the root element, I have to make sure none of the child has that visibility visible applied to it. So again, my friend talked about developer experience a lot in the last session. This is a bad developer experience to me, correct? I'm facing a lot of issues just to make two technologies work together which are not working best of it. Another problem on the same thing is that when I'm saying there is a slot, if I have to change anything dynamically on that slot, correct? My web component was not able to understand that. So let's say if I slot have an attribute which is going to change by any change in state of a React component, correct? If once that web component is registered with that slot, later on if the attribute was changing, it was not applying the same. So you have to add that functionality somehow in the web component saying that, oh, continue reading that change, or continue watching that change in that properties of the slot. Okay, cool. So last issue that I'm going to discuss is hydration errors. And if you have used Next.js, you would have seen that hydration error occurring a lot of times, correct? Cause of different reasons. So what is hydration error? It simply says if the server and client markup doesn't match on the initial render, it will throw you an error saying that, oh, the markup does not match. So that means there's some problem the way you are rendering your code. Why this happens is, so imagine that there is a team which is creating that design system library, which is not aware that this is going to get used in an SSR app, correct? So they will add functionality whatever works for them, and it is very common to use window or global methods in the web components APIs, correct? You have to, for example, if you have to register any custom event, you will say that window.add custom event, correct? There's no other way. But that window as an object is not available in any SSR based app, correct? Because it's a server side rendered one. So server doesn't know what is window. So it will start throwing you those errors. And if these two teams are working totally separately, one team is just creating those components suddenly which is getting consumed in an SSR app, they will start seeing that hydration error, or this has failed, this is not working out. Attribute properties mismatch because of client level registration again. One of the problem that we faced was that we were trying to solve direction, correct? We were actually building a global app which was used in the Middle East countries as well. So we have to handle the direction attribute as well, from right to left, left to right also. So that direction attribute was getting that value dynamically. So what we were saying that in like my initial render says my direction is left to right, but when I was rendering on the browser, because if I was rendering on a Middle East country, it changes from right to left. So it was saying that there is a hydration error because of that. So how do you solve that? Again, the way we tried, don't use or at least check the presence of window object in the web component entry logic. That is a point mentioned in the Next.js docs as well. If you are facing hydration error because of window object, just check if it is undefined or not available. If it is defined only, then do that. That is one way you can solve that problem. But again, if two teams are totally separate, this is very hard problem to solve because you have to go back and ask them, oh, can you not do that? Second is avoid using dynamic attributes in the web component host elements. So web component again has a concept called host element, a root element within that web component. So one thing we again realized was that if we are using a dynamic attribute on the host element, that is when these kind of hydration errors were triggered. But if you don't do that and use it on a div like nested inside a host element, we were not facing that issue. So these are the four major issues that we faced, at least, but there were others as well. I'm not going to go in details of that, but in general, what we also saw that with web components in SSR app, we could see cumulative layout shift. Everything relates back to that web component has to get registered on the client. And that is what SSR apps doesn't want you to do, correct? So cumulative layout shift, because let's say if you have a height applied to any component, correct, which will applied only when it gets registered. So as a tool, I'll see that as a layout shift because suddenly it will just jumps out. Just imagine how it will do that. But if you use any tool, it was actually telling us saying that, oh, these are the icons which are having some layout shift once it is getting registered. Unit testing the React components using web components. So this issue is not specifically related to an SSR app, but in general, what we faced is that when you are using web components in a React-based app or any app, any framework-based apps, it was hard to write some of the unit tests. And one example, I hope you folks will be able to relate it to that. Let's say if I have to write a unit test for an input saying that whenever I change that input, I want the form to get submitted to this particular API. So I'll say that my this function to have been called with this input, correct? That is how you will write the unit test. But since in my unit test, the web components were not getting registered, that change was not triggering in the unit tests. So another problem that we faced. Library version mismatch in the micro front-end architecture. And this is a very big one. We were facing that multiple times. So again, if you have a micro front-end architecture where different components are coming from different micro front-ends, and each of those micro front-end is using the same design system library, correct? How web components will get registered is that whatever comes in the last is your final web component. So imagine that you have three different components from within a page, correct? From three different micro frontends coming in. But I have updated the library version in the third one only. If the browser executed the second one in the last, your change will not reflect everywhere. So another problem, there's a very big blog on the same topic. How can you solve that problem? But it's a mess. So if you can avoid that. And last but not least, accessibility issues. Because of your shadow root element, correct? Again, one example, random example that I'm throwing you. Within that shadow root, correct? A lot of times your accessibility works with IDs. One of those examples is ARIA controls, which needs IDs. So if that ID is within your web component shadow root, it will not identify that. Because again, it doesn't understand where it is defined. So you might face those kind of issues as well. So in the end, so before that, like because of all these issues, correct? Though we discussed about resolutions of most of them, those as well, but do you really want to invest in that? Or you want to work more on the feature stories, implementation, rather than solving those issues where these two things are not working together, correct? So we realized those problems, and later on actually we moved back to the React design system components only rather than using the web components. And that was a learning for the whole team. So what are the recommendations here? Don't try to fit in a solution, correct? Again, Tane talked about that, correct? Don't try to use something which is resume driven. Web components are hot topic, SSR is a hot topic, but try to fit in what works best for your application, correct? If you know that the whole ecosystem, whole application ecosystem is revolving around one framework, don't try to fit in just for the sake of reusability here. Oh, later on, or if I'm on the React ecosystem, suddenly I'll say, oh no, later on this is future proof. If I build a page in Angular, I can use this there as well. That's too futuristic, correct? You are trying to solve something which is a problem right away. Solve that first in a better way. So don't try to fit in a solution here, which doesn't work. Second, for me is a very important aspect. Evaluate the solution with different scenarios before jumping to the conclusion. So one of the problems that we faced here was that because these were two different teams altogether who were creating that design system and the one working on that SSR app. Although they know that these are going to used in the Next.js app, but they evaluated it with some very basic scenarios. So when we started using that library in the Next.js app, that is when we realized all these issues. So if you are going to fit in a solution, make sure that you are evaluating that against different scenarios before jumping to the conclusion that this is the best fit. Don't do that. And last but not least, involve stakeholders from different teams. Don't build in silos. If you are in a distributed team and you are working on a very specific set of solution, try to involve stakeholders from the different teams. And design system is a big thing. You are building design system to be used in different teams, not for a single one, correct? Maybe involving stakeholders from different teams, they will tell you the different scenarios, different problems that you might face with a particular technology. So try to include those. There's a term used called design guilds. So try to create design guilds in your system. So with that, I'm done. That was all I wanted to talk about. So I'm Vishal Sharma. So I'm a lead front-end engineer with over a decade of experience with mostly front-end technologies. I've been working on high performance, pixel perfect kind of an apps from the last few years. So these are my profiles: GitHub, Medium, and LinkedIn. So reach out to me if you have any questions. Thank you.